Assalamualaikum dan selamat sejahtera kepada para pelajar yang menghadiri program Perkongsian PINTAR Perkampungan Ilmu Semester 3 STPM 2021 Kimia. Anda bersama dengan saya, Cikgu Chua selaku pengurusi majlis pada hari ini. Kamu boleh dengar suara saya tak? Kalau boleh, sila bagikan reaction ataupun boleh reply dekat bahagian chat. Okay, baik, terima kasih. Bersama-sama dengan kita juga adalah yang berusaha Datuk Dr. Noel Robert selaku Pengetua YPC International College, Encik Muhammad Yusof selaku Pengetua Kolej Tingkatan 6 DESA MAHKOTA, yang dihormati Dr. Farah Robert selaku Pengarah Usaha YPC International College, Puan Aisyah iaitu Penolong Kanan Kolej DESA MAHKOTA, Puan Wijaya Laksmi, Ketua Unit Pengurusan Sains dan Matematik, Puan Mageswari, Ketua Unit Kimia, serta barisan AJK daripada Kolej DESA MAHKOTA dan juga YPC serta JPN KELANTAN dan juga Terengganu yang banyak bekerjasama menjalankan program pada hari ini. Terima kasih diucapkan. Tidak lupakan guru-guru sekolah, guru pakar yang merupakan guru jemputan kita pada hari ini iaitu Puan Chua, serta semua pelajar-pelajar SPM Semester 3 yang bakal menduduki peperiksaan tidak lama lagi. Okay, terima kasih kerana sudi menghadirkan diri ke dalam program Perkongsian PINTAR Perkampungan Ilmu Semester 3 STPM 2021 bagi subjek kimia. Untuk makluman semua, program ini dikaji sepenuhnya oleh pihak YPC International College dan juga PIBG Kolej DESA MAHKOTA. Bagi para pelajar yang belum lagi join program ini dan juga belum join Telegram, sila berbuat demikian kerana kita akan hantar nota-nota jika ada dalam grup tu dan juga informasi atau perubahan terkini dalam grup tersebut. Okey. Baiklah, tujuan program ini adalah untuk membantu semua pelajar STPM Semester 3 2021 untuk meningkatkan prestasi menghadapi peperiksaan yang akan datang. Tanpa membuang masa, sebagai upacara pembukaan, saya akan menjemput yang berusaha Datuk Dr. Noel Robert untuk memberikan ucapan. Dengan segala hormatnya, dipersilakan Datuk. Lupa pula nak introduce pun.
I don't hear them. Oh, okay. I can't hear. Sham, good morning. Am I supposed to start now?
Yes, Datuk.
Hello.
Hello, Datuk. Yes, Datuk. You have to start now. Thank you, Datuk.
Can you hear me? Okay. Okay. A very good morning to everyone on a cold morning. What a warm news for all of us. And a good welcome to semua pegawai JPN, pegawai PPD, guru-guru, students that is involved in this program called Program Perkongsian PINTAR Perkampungan Ilmu or Score A STPM Semester 3. And the first topic is so meaningful, chemistry. Student, I want parents, student, pegawai-pegawai JPN, cikgu-cikgu, I want to share with you. It is because of the chemistry of working together with YPC International College, Liverpool John Moore University, and pegawai-pegawai daripada JPN all over Malaysia. And I must record my highest appreciation to to KOLEJ Tingkatan 6 DESA MAHKOTA, a big thank you because you all have organized this so well and you all are willing to share the expertise of teachers not only with your school but with all over Malaysia. Terima kasih tidak terhingga. And to the team in KOLEJ Tingkatan 6 DESA MAHKOTA, Tuan Muhammad Yusof bin Ibrahim, Pengetua KDN, Puan Aisyah Banu binti Karnain, Penolong Kanan, Puan Wijaya Lakshmi, Ketua Unit Pengurusan dan Pentadbiran Sains, Puan Maheswari, Ketua Unit Chemistry, KOLEJ Tingkatan 6 KDM, and all the teachers that are involved in this program, or everybody that helped to make this program a success, all JPN, staffs of YPC, I'm so proud of you. And students, take advantage. We'll be having subjects until April. So take advantage. This is the first time that we are organizing for STPM. What is our objective, student? Successful people say, if you want to do anything, successfully, you must plan. You must know what you want. You must communicate. And this is what we are doing for you, students. And why we want to do this? Because we want to prepare you to score in your STPM. When you score in your STPM, when you continue with your degree, you are going to become successful. You are going to pass your degree with first-class honors. So take advantage. And the other reason why is to make you familiar with the exam structure, overview of the exam, major topics, time management, how to answer questions correctly, and to gain maximum marks. So please focus, student. Harap pelajar fokus dan ikut teknik from guru-guru pakar. And today, the star of our program today is Cikgu Chua. Cikgu Chua is a pakar guru kimia, retired but willing to share. Thank you, Cikgu Chua. Thank you very much. And Cikgu Chua is from SMJK Jitsin, Bukit Mertajam, Pulau Pinang. More than 40 years of experience to share with all of us. Terima kasih tidak terhingga. Once again, thank you everyone. And I'm so happy that this program has started, and it is the first time YPC International College together with KOLEJ Tingkatan, we are doing it together with Form 6 STPM. So thank you very much. And now I want to hand over the mic to our senior lecturer, Ms. Gan. Thank you and all the best.
Good morning, everyone. I am so happy to be given this opportunity to be able to talk to you. Follow from what Dr. said, YPC International College is in collaboration with University. So I am going to take a little bit of time to introduce our business management program. So as far as I know that today this session is about Kimia, but if business is a pathway that you would like to go in, and let me explain a little bit of after your STPM, what are you going to do with a business management degree? So over here in YPC International College, in collaboration with Liverpool John Moores University, we are having a business management program that is very unique, and we call it Bachelor in Science Business Management. So in this particular program, you are going to be offered with a certain, quite a number of specialization in our business management program. So for example, we offer digital analytics, we offer entrepreneurship, we offer people management, project management, finance management, as well as marketing and product development. So these are all the practicals and also very useful area of business instead of focusing on theory, because the business management program is designed by Liverpool John Moores University from the UK, and their focus is to equip the graduates with all the skills and specialization needed to get a job. So, for example, a lot of our graduates, after they have completed the program, they are actually working multinational companies, and they can also apply whatever they learn in this business degree into their work life. So right now you are in STPM. I would like to congratulate you because you have come into this journey of STPM and you are going to sit for your exam soon. And after this STPM, you come into a decision of which pathway or which degree that you want to go in. And after your STPM, you are able to direct and enter into our business management program in collaboration with Liverpool John Moores. So if you want to know further details about this business management, free to reach out to us so that we can explain more on your potential to be a businessman or a businesswoman in the future. Thank you very much. And I would like to pass the time back to our Chua today. So, guru jemput yang akan mengajar kimia pada hari ini ialah Cikgu Chua, with the experience mengajar kimia selama 40 tahun dan kini sudah bersara. Dengan segala hormatnya, dipersilakan Cikgu Chua. Thank you.
Yes, I'm Chua here. Can you hear me? Can you hear me? Okay. So can you stop sharing the screen? A very good morning to Datuk, Ating, Ketua, guru-guru IJK. Without wasting time, I would like to start the session now. Okay, before I start, I would like to remind you, I remind the student. Okay, my session will be supposed to be 2 hours. 2 hours, right? 1.5 hours is for presentation, my presentation, and half hour is for Q&A. As now it is already taken more than 50 minutes, about 20 minutes for the open ceremony. So I think I may not be able to finish all the slides I prepared. I have prepared 60 slides. If time is not permitted, likely I will stop at 50 slides without the amino acid and polymer. So the amino acid and polymer should be discussed separately. Okay, then I would like the student to prepare some paper so that you can write the main point, or you can write out what question you want to ask later in the Q&A session. Right? Please be reminded to mute your mic. As I have more than 40 years teaching experience, teaching chemistry from 6. So I've gone through teaching in mathematics and science in English. After that, we shift to Malay medium, then back to English medium again. So my pronunciation will be, for the chemical compound, will be in the English term. So many of you are taught by a Malay medium teachers. So maybe you'll find it a bit different. Like I find that many of my tuition students, are called methyl. Why methyl? Is meta and not methyl. Methyl is the bahasa Melayu. Then I will pronounce it at meta, eta, okay, and so on. So you may not be so familiar. So sorry, I have pronounced it in the correct way. Okay, next one. My screen is a full screen presentation. Mine is the full screen presentation. So I wouldn't be able to see your chat. Okay, so I only look at your chat, your message in the Q&A session. As I was told that they'll come in, maybe will be 1,000 participants taking part. So I may not be able to answer all the questions as you ask. Anyway, I will try my best. So shall I start? Can you see the slide? Can you hear me? Can you see the slide clearly? Someone please comment. Okay, I'll see.
Yes, teacher, we can hear you very clearly.
Okay, thank you. So we shall start. Okay, so this is the chemistry, term 3, organic chemistry. So we say, like organic chemistry, mainly we have what type of question? Okay, general. So for a start, the question, you usually start with general term. What do you mean by general? You'll come to it later. Conversion, this type of question, conversion question. Then draw the structure of the organic product. When something, when X reacted with what it is supposed to be under conversion. Under conversion. Okay. Then you have question like distinguish, give a simple test to distinguish between the two organic compounds. Then we'll talk about it one by one. Then state and explain the observation when A is treated with something. And lastly, identification. So we go one by one. Okay, like first, general. What do you mean by general? So usually we start there. You have the what is the function? What is the systematic name? Systematic name also called as IUPAC. IUPAC naming. Okay. Then what is the naming for this one? Then what is the function group? What are the function groups present in this compound? Okay. And what reaction in step 1? What type of reaction in step 2? And what type of mechanism? Reaction and mechanism is totally different. So I use the laser pointer. Okay, this is reaction. This is mechanism. So they are different. We'll come to it. Next one will come to isomerism. Very common. Very often you will see question on isomerism. So how to tackle the question on isomerism. Then next, how structure affect the acidity and basicity. Question, very few questions on this type. Okay, a few years, then you see one question on it. But this type of question, if come out, usually will be in objective question. And lastly, the solubility in water. This is called general. Whether this compound soluble in water or not. Okay, we go like naming. Like naming, we have the IUPAC naming or called systematic name of, for example, I have this one. So if it's IUPAC naming or systematic name, it had to be called as chlorometabenzene. But if it name this the above compound, just name above compound. So it may not have to be IUPAC, PAC name. Then it can be named in the commercial way or the formal naming. But if once you stated IUPAC name, it must be chlorometabenzene. Chlorometabenzene. But name this above compound, I can call this as chlorometabenzene is the alphabet name, and I can call this one as benzachloride. It's a name without saying the systematic name, without mentioning the IUPAC name. Then I can call this one as the benzachloride. Similarly for the amine, CH3NH2. So maybe many of the teachers just pronounce that what? Metaamine. Metaamine is not the IUPAC name. The IUPAC name is called, sorry, it's like CH3NH2. So maybe your teacher calls metabenzene. Sorry, metaamine, metaamine. But alphabet name will be methane, methylamine, methylamine, methane, cancel the E, amine, methylamine, methylamine. So this is called alphabet name. So you just check out with your teacher. Okay, right, we go on to the next one, function group. Very often you will have question on function group. Function group. Okay, so for example, I have this compound. Function group. Name the function group. The function group, the function group must be made. So what is the function group? Then you can put hyphen NH2, hyphen Br, hyphen CO NH2. So but it name, then you have to name. This is the function group, and this is the function group, and this is the function group. So when you name, this will be amino, bromo, and amide. Amino, bromo, amide. Okay, next example. Then this is the amino acid. Okay. What are the functional group present in this compound? So I have this one. NH2 is amino, or it's called hydroxyl. Hydroxyl, not hydroxy. Hydroxy is the name. Hydroxyl is the function group. Then carboxyl. Carboxyl, not carboxylate. Carboxyl. Carboxyl. Okay, another one. I have this paracetamol. What are the function group? So you'll find that you have the phenolic group. Phenolic group. When the OH is on the benzene ring, we call it a phenolic group. Then, if you also, I can call hydroxyl. Hydroxyl. Okay, amide. But if the OH is on the benzene, I can call this one as phenolic group also. Yeah, next one. Type of reaction. What type of reaction? We only have 3 types of reaction. Actually, we have 4 types of reaction. But one type reaction is out of our syllabus. That is rearrangement. So we are leaving only 3. Substitution, addition, elimination. But when you ask what type of reaction is step 1, what type of reaction is step 2? So if the reaction have a special name, then we have to put the special name. Okay, for example, what type of reaction? Oxidation. What type of reaction? Reduction. What type of reaction? Hydrolysis and dehydration. Dehalogenation. Dehalohydrogenation. This halohydrogenation actually is elimination. So if there's a special name for it, you have to go for special name. But if there's no special name, like alkene plus bromine, you don't have special name, then you go for addition. You go for addition. But if there's a special name, you have to go for special name. Okay, like next one, isomerism. I will spend a bit of time of isomerism because I find that what should I say? Never mind. We say isomerism. We don't talk about others. Okay, isomerism. But isomerism mechanism and the effect of structure on the strength of acid and base. Okay, like we go for isomerism first. Like isomerism, we have structural isomerism. And we have the stereoisomerism. So under stereoisomerism, we still have 2 types. Geometric, optical. So we have to know the definition. What's the definition for structural isomerism? What is the definition for stereoisomerism? And what is the definition for geometric and optical isomerism? These are the marks. You must know. Okay, what's the definition? Then when many students will get confused. When do I draw structural isomerism? Structural isomers. When do I draw stereoisomer? So you watch out. Okay, like okay. If I give you C4H10O, C4H10O is the molecular formula. Okay, this is the molecular formula. When you're given molecular formula, you have to go for structural isomers. You also have to go for stereoisomers. Once you're given molecular formula, you have to go for 2. For example, C4H10O. I have this one. 1 butanol. 2 butanol. 2 metapropane 1 ol. And 2 metapropane 2 ol. So I have 4 structural isomers here. But you look at the second compound. There is the hydrocarbon here. There's a hydrocarbon here. So we have to go for optical isomer. Hydrocarbon here. Then we have to go for 3 dimension. Okay, so I go for this one because it's easier for me to in the computer. But to actual one, you should go for this one. It's the dash step is the triangular form. And the triangle is the solid form. So we have 2 solid lines, 1 dash is the triangular form, and 1 solid form. Okay, but I will use this way. You know that I will get over here. And then I go for mirror image. Go for mirror image. Okay, and then for my different student, you see, my school teacher will ask this C2, you see, ask them to what? Is C2 is 5. I have to invert the C2 is 5 as a mirror image. No, this is a group. This is a group. So I don't have to put C2, the C, then 2 here, then H, and then 5 here. No need. This is just a mirror image of the compound. So this is the group. This is the group. This is the group. This is the group. Whatever you need, what is important is what? The bonding must bond to the correct atom. So this one bonded to the C, bonded to the C, bonded to the H, bonded to the O, and not H. That's all. Okay, I see some more. Yeah. Okay. This is an amino acid. Amino acid. So this is a structural formula. That means the structure is already out. The structure is already out. So if you want the structure is all out, you cannot go for structural isomer. No more structural isomer. This is structural formula already. So I only go for serial. So what type of serial? There's a chiral carbon there. So I go for optical isomer. I only go for optical. So you ask you for the isomer for this compound. So you only go for optical isomers. You never go for CO. Can I put my NH2 to some other place? No. This is already a structural formula. So a structural formula, you only can go for serial isomer. Either it's optical or geometry, but for this case, it's optical. Yeah. Now from there, then I go for here. Okay, next one. Okay, look at this. I purposely choose this one. You see, this compound has 2 parts. This part, P, gives the structural formula for the isomer P. So look at this P here. I have this group, phenolic group here. Phenolic group here, this is already in structural formula. So you cannot touch. You cannot change the OH to other place. Then this OH is on the number 4. According to the C2. Then relatively to the C2 is 3. I'm in number 4. So I change it to number 3. I change it to number 1. And number 2, and so on. No. This part you cannot change. It must be fixed to this part. This part is the structural formula. This is structural formula. This part is the molecular formula. This part is molecular formula. Structural formula you cannot touch anymore. Only the molecular formula you can change. So it means when you draw, this part remain unchanged. This part remain unchanged. Only the C2H3 go for isomer. C2, CH3. CH2, CH4. CH4. You cannot touch here. You cannot change the no. So this is the structural formula. Over here, there's no hydrocarbon. Neither there's cis and trans isomer here. So this will be the 2. You please, anything, you see that, I have a question on this one. Then you just put a note that, I want to ask on this isomerism. Okay, so if the teacher is with you, maybe you can ask the teacher help you to ask any question. Again, come to this one. This is structural formula. For sure, this is structural formula. It's called 1 phenol build 1 in. 1 phenol build 1 in. Okay. So this is structural formula. I only go for stereo, and this type stereo definitely is the geometric. Geometric isomer. Geometric, I go for cis and trans. Cis and trans in the sum of X. The 2 compounds are in the plane. The 2 similar groups are in the same plane. I call cis. So only 2. I cannot change the double bond to here. I cannot change double bond to here. So if you're not clear on this one, you find that you tend to get yourself confused. Don't know how to do. Once the structure formula out, you only can go for stereo. Okay, so if you have question, you can ask. Like now we come to mechanism. Okay, right? Mechanism. So we have 5 mechanisms. Free radical substitution, Electrophilic addition. Okay, I'll go for substitution first. Free radical substitution, nucleophilic substitution, electrophilic aromatic substitution. Aromatic must there recently, not so recently, but sometimes they changed, they must have aromatic there. Then addition, you have two, electrophilic addition, nucleophilic addition. So all the mechanism on the elimination is not in. And the free radical addition also not in. So you only have 5 in your syllabus. So for all these 5, you must know what are the examples. What are the examples go for free radical substitution? What are the examples go for each of it? This one is a must. So if your teacher haven't taught, maybe I find that I can share with the teachers. If you haven't taught this one, you're not in detail on this one, you can teach them again. Because you still have 2 months to go. 2 months to go before your examination. So you can go one by one. It is a free radical substitution, right? If you see this compound, they look for this part. One by one. So teacher, if you have a question, you just jot down, then you discuss in the Q&A session. Okay, like see, only the nucleophilic substitution. Nucleophilic substitution. You don't accept nucleophilic substitution. It is a haloalkane. Haloalkane. You have to go for unimolecular nucleophilic substitution, SN1, or bimolecular substitution, nucleophilic substitution, that is SN2. You cannot just put nucleophilic substitution. You have to put together, whether it's unimolecular or bimolecular. Okay, go on. Right. For example, by using a suitable example, describe the mechanism of the electrophilic aromatic substitution. I want a suitable example. You must give me an example. So what example? Must be benzene. Start with the benzene. Then I can go for alkylation. I can go for nitration. I can go for halogenation. But in your syllabus, you're told that we are going to illustrate the electrophilic aromatic substitution by alkylation or nitration. So your teacher probably have taught you this. So we use the example. You write the equation. You write the equation using benzene plus what, and so on. So today my session is to tell you the important point, how you tackle the question, and not teaching. I'm not going to teach you. So if you find that this part you're not clear, you ask your teacher, please. Okay, like equation. Then you show the step involved in the mechanism. So with the free radical substitution, then I need to show the half-headed arrow for the free radical. If it's a nucleophilic or electrophilic, I have to show the arrow full-headed. That means the double-headed. Not reversible. Is the arrow is a full-headed. Okay. Then to show the nucleophile, I take the nucleophile. All these you must show. Whenever there's a polarity there, delta positive, delta negative, you have to show the delta positive and delta negative. Okay, go on. Describe the mechanism involved in reaction 1. So sometimes they give a reaction scheme. Then they want you to describe the mechanism involved in reaction 1 or in step 1, step 2, step 3, whatever. So you have a reaction scheme. Then give the mechanism for the reaction 1. Describe the mechanism. Although you ask to describe, you don't have to describe. Just show by equation. Let's say, for example, it's a free radical substitution. You show by initiation. Then you have 2 steps for complication. Then we go for termination. Okay. So over here, I have to give the name. For this step, I have to give. Unlike here, the name is going out. Electrophilic aromatic substitution. The name is already out. The name of the mechanism is already out. So, but this step, what type is a mechanism? Give the mechanism, describe mechanism. I have to tell me. This reaction 1 undergoes free radical substitution. For this reaction 1 undergo electrophilic aromatic substitution. I have to mention first. Whether got mark not. Okay, whether got mark not up to the marker to mark. We will know. You just write out. And after that, again, I need the equation. The equation, overall equation. Then only I go for the step. Write out the step involved. Step for the mechanism. Okay, So this will be on the mechanism. Okay, right. Next one. For example, the compound with the formula shown with hot aqueous sodium hydroxide solution. Compound. Then the question asks, name the type of reaction. What type of reaction is it? Okay. Then name the type of mechanism. What type of mechanism? What the full structural formula of product? What will be product when this one reacted with a hot aqueous sodium hydroxide solution? Okay, so explain the difference in the reactivity of chlorine atoms in the molecule of the two Cl atoms here. Are the reactivity same? Answer is no. So you ask to explain the reactivity between the two chlorine atoms in this molecule. So we see the type of reaction is the substitution, but there's a special name. So this is the alkaline hydrolysis. Alkaline hydrolysis. And what type of mechanism? This is the primary halogen. Primary halogen go for SN2. SN2 is a bimolecular nucleophilic substitution. Bimolecular nucleophilic substitution. When you say name, you name. What is the mechanism? You can put for SN2. But name that you name bimolecular nucleophilic substitution. Okay? And draw the full structural formula for the product. Then this like it is. So I'll contact the Cl on the sub-branch here will change to OH. So I draw this one. Okay? Those parts without reaction remain unchanged. Only the Cl change to OH over here. That's all. And explain the difference in the reactivity between the two chlorine atoms in the molecules. So there, I will say that, okay, the chlorine atom at the side branch, this is called side branch. Okay. A chlorine atom in the side branch is more reactive than chlorine atom attached to the benzene ring. This chlorine over here in the side branch is more reactive compared to the chlorine at the benzene ring. Okay. This is because the C-Cl bond, at the benzene ring. The C-Cl bond, Cl here, C-Cl bond here is strengthened by delocalized electrons. So to go for hydrolysis, this is very difficult. You have to undergo very rigorous conditions. Then only this one can undergo hydrolysis. If not, only this one. Yeah. So I cannot really wait for you. You have to be a bit fast. Otherwise, really, with the speed now, I want to go to 50 also quite difficult. 20 minutes already taken away. Okay, under different reaction conditions, metabenzene, right, with chlorine by two different reaction mechanisms. This is the question. There are two different. First reaction, I get here, chlorometabenzene. Second reaction, I get 2-chlorotoluene. 2-chlorotoluene. Okay, so I go Ready? The reaction and condition required for the reaction 1 and reaction 2. I want to state the reaction. So the reaction has to be in formula. It cannot name. Oh, I cannot name as what. So over here, I use the chlorine in the presence of what? Ultraviolet light. So I cannot put CHLORIE in the reaction scheme. I must put Cl2. Okay. Then the light here is to be UV light. UV light. Or you can put H mu. Okay. Whereas over here, so I go for halogenation on the benzene ring. That is electrophilic aromatic substitution. So this time I'm using chlorine in the presence of catalyst. The catalyst is Al-Cl3. Al-Cl3. Room temperature optional. Optional means you write one write also can, you don't write also can. Yeah. Mean the type mechanism involved in the reaction 1 and reaction 2. It's a free radical substitution. This one is the electrophilic aromatic substitution. Yeah. Describe the mechanism involved in reaction 1. Now this one I want to describe the mechanism. Okay. So I have to give the equation. The equation is not in I will written just now. The part 2, I will say what is the mechanism. So I don't have to mention again, but the equation is fast. Then you follow by the initiation, propagation, and the termination. Okay, come to next. How is the structure affect the acidity and basicity of the acid or base? Okay, over here, like I just give a short one. Okay, like is this speed okay or not? Do you find that I'm going too fast? You can just on the mic for a while. And do you think it's too fast? If no complaint, I'll go on this speed. Yes, a bit too fast. So I go a bit slower, but you have to prepare. If I will be slower, definitely I cannot. But I will be less likely to be discussed. Okay, right. So I go a bit slower. How is the structure affect the acidity and basicity of an acid or base? So a few points we have to remember is what? Okay. What is the? Okay. What are the acidic group in the organic compound? What are the acidic group? So the acidic group are carboxylic acid and the phenol. Only carboxylic acid, any carboxylic acid and phenol are acidic compound in the organic chemistry. Okay, and among the acid compound in the organic chemistry, phenol is the weakest. We talk about acidic compound, so phenol will be the weakest. Okay, like so if you ask arrange the following compound in the ascending order of acidity, for example, I give ethanol acid, phenol, benzoic acid, chloroethanol acid. I want to arrange them in ascending order. So I will write phenol will be number 1. Comma. You don't put bigger or smaller. It's the order. Just put comma. Followed by ethanol acid. Followed by benzoic acid. Lastly, chloroethanol acid. This is only 1 mark. 1 mark only. So in any arrangement here wrong, in between here wrong, will be no mark at all. Either 1 mark or no mark. Like one. Next. Among the carboxylic acid, carbonic acid is the weakest. So we have the COOH. Okay, not including phenol. Phenol don't have COOH. So among the carboxylic acid, carbonic acid is the weakest. So if you have arranged the following compound in the ascending order of acidity, again I have this one: carbonic acid, phenol, ethanol acid. So you find that ethanol is the alcohol. All alcohol are neutral except phenol. So the name I will put the ethanol number 1. Then followed by phenol. Phenol is slightly acidic, but phenol still leads to carbonic acid. You know, carbonic acid is the carboxylic acid. Okay, lastly, ethanol acid. Okay, like next. Come to amine. Among the amine, aniline is the weakest. Aniline also called as phenamine. Phenamine is called aniline. Aniline is the weakest. And it's two direct attached to the benzene ring. It's called phenamine. Okay, our pet name is aniline. Okay, arrange the following compound in the ascending order of basicity. So watch out, not always ascending, sometimes descending. Descending will be strong to weak, stronger to weakest. Okay, like that one. Methylamine, ethanamine, and methylamine. Aniline. So aniline, all these are amine. Aniline will be the weakest. Then followed by methylamine, followed by ethanamine, and last one will be methylamine. Okay, let me summarize. I give an example. This is aniline, and this is phenethylamine. phenethylamine. Okay, so you find that which one is more basic, answer must be this one. If it's this one come out in operative, straight away. If this one come out in essay or structure, but very unlikely, very few question now in essay. This type of question very few in essay. So maybe you have one or two pop out in the structure. Okay, so the reason is what? It's better on the aniline. Aniline is the weak. Okay, why? Because the lone pair on the nitrogen here on the aniline can undergo delocalization. Delocalize into the benzene ring, causing aniline is less likely to accept proton. You want to be a base, you must be able to accept proton. But your lone pair is responsible to accept proton. Or your lone pair delocalize into the benzene ring. So making it less likely to accept proton will be a weaker base. Like so A, COH. And for this acid or carboxylic acid, and this is base. So see, I summarize it. To be a stronger acid, I want this acid to be a stronger acid. A group here has to be a electron withdrawing group. Think about what do you mean by electron withdrawing group? So you ask the teacher, I cannot teach here. Okay, and then reverse. If it's a base, the group B there. To be a stronger base, the B and the group B here have to be an electron donating group. Electron donating group. So this will be the how the structure affect the acidity and basicity. Okay, go on. You see this one. Okay, I'm supposed to stop at 12 o'clock. Okay, then half an hour for the Q&A. So now it's already I only leaving in 45 minutes. Right, 4 major types of organic question. 4 major type, right? You look the depends on whether you read you study your organic well. Easy. So will be easy. Some question on conversion is quite easy, but some are difficult. I will show you example because almost without fail, you see every year question, you have conversion, you have identification. You have question on conversion. You also have question on identification. Identification usually will be in essay. Conversion can be in essay, can be in structure. So almost without fail, you check the past question. Okay, so we see like conversion. You see several way they ask on the conversion. So number 1, step 1, draw the structure formula for the product when C2H5 MgPr with a good reagent. Now 1, 2 step reaction 1 and 2. I want to get the draw the structure. Draw the structure of this compound. Okay, draw, you must show bonding. Okay, so when I go here, I get here. I don't have to show all the bonding there. Okay, but I show part of the bonding. Where is the or draw? But I cannot go for condense. Draw, I do draw. Then see another one. I have this compound. Okay, then go for what? 1, 2. Ethanolic KCN H2O stroke H positive. So that means this part is on the BR. If you learn organic well, you learn function group. You don't teach this compound you what. You learn function group. The BR will change to CN. The CN step 2, CN will change to COOH. That's all. The rest unseen. The rest will be unseen. This is called conversion. See? 1, 2. Okay, so this is the reducing agent. Be careful, reducing agent. So what are the functions can undergo reduction? Find that over here, there are 2. One is on the COH, one is on the CN. So you see, how do I know if whether you study the subject well or not? Okay, the COOH here will reduce to primary alcohol, and the CN here will change to primary amine. This is called conversion. One type, Okay, I have this question come out recently, 2020. This is a structure formula for estradiol. Estradiol is a hormone. So here, mean one functional group in the estradiol. So I can call this one hydroxyl. I can call this one as phenolic group. Okay, write the structural formula for the product. When you say product, it must be organic product. You don't write me H2O. You don't write me HCl. You don't write me CO2. I want the product must be organic product. From when estradiol regular with the following reagent. So you copy this one exactly. Look at this compound. Where are the functional groups that go for reaction with the P sulfide? This is the test on the OH. So I have OH here, I have OH here, but this OH on the benzene ring cannot react with P sulfide. Why? Please ask the teacher. Then only here. So I just change to Cl. That's all. The rest remain unchanged. It may look very complicated, but the answer is simple. Just change where the place you need to change. NaOH NaOH go for hydrolysis. NaOH also can go for neutralization. So you find that this compound cannot undergo hydrolysis. Then say, how do I know? Then your teacher had to teach you. Okay, I know here definitely will be neutralization because there's a phenol here. So my answer will go to O and A here. The rest remain unchanged. Okay. Part 3, starts with concentrated sulfuric acid at 160 degrees Celsius. This is hydration. Hydration is on alcohol, but not on the phenol, on the alcohol. So you just draw exactly, then put a double bond here. That's all. Okay, lastly, bromine water. Bromine water is on the phenolic group. So I just draw this one actually here. Okay, on the 2, 4, 6. 2, 4, 6, but the 4 is already blocked. If it's already blocked, let it block. Only go for 2 and 6. That will be a answer. The rest remain unchanged. Yeah. State the types of reaction in part B, part 3, and part B, part 4. Part B, part 3, and part B, part 3. Type of reaction. Dehydration, or call this one elimination, but usually we ask the student to write dehydration. And part B, part 4, part B, part 4. This is the electrophilic aromatic substitution. You cannot call this one halogenation or bromination, because bromination, this part is not only the phenolic, it's a phenolic group. Phenolic group, because of this, go for 2, 4, 6. So this one we had to go for electrophilic aromatic substitution. Right, next. Right. This is the expecting become the very complicated. Don't have to worry. This is the very complicated. Let it be. Then see what question we ask. What are the functional groups? I mean, there will be more than one. There will definitely more than one. In that expecting. Expecting is a sweetener, artificial sugar. Okay. So you have the amino, can see that? You have the amino. Okay, I've finished the question. Can expecting be solved in water? Asking your answer. Okay. Draw the structural formula for the organic compound. When expecting, you have number 1, phosphate pentachloride. Number 2, hot aqueous solution of sodium hydroxide. So this part, this is on the conversion. Over here, you see that what are the functional group? Functional group, carboxyl group, amino group, amide group, benzene ring here, and the ester. Then can aspartame dissolve with water? Can aspartame dissolve with water? So over here, please watch out. To be able to dissolve water, you must have a OH group. You must have an NH group, and you must have the NH group or OH group. So over in aspartame, I have OH group, I have NH group, I also have NH group over here. So look like, okay, can it dissolve? So sometimes you find that it can dissolve. Sometimes you say cannot dissolve. It depends on the hydrophobic group. So, but this type of question, how to answer? You are told that this is the artificial sugar. Artificial sugar definitely can dissolve. Don't tell me you put the sugar in the coffee, then it's solid. Definitely it can dissolve. So use your intelligence to answer. Then is it asking the answer? Because aspartame contain OH group, contain NH group. So they can form hydrogen bond with water molecule. They can form hydrogen bond with water molecule. Okay. What? We go for the last part. Oh, the structure formula for the when aspartame you have it sulfide. That's for OH. So here change to CR. That's all. Hot aqueous solution or sodium hydroxide. This is hydrolysis. This is hydrolysis. Hydrolysis and neutralization. Hydrolysis together with neutralization. So I have the carboxyl group can go for neutralization. I have the amide group can go for hydrolysis. I have the ester group can go for hydrolysis. So you go for the change. Because this part is more difficult. Okay, this is a P-sulfide one. Hydrolysis together with the neutralization. So amide can go for hydrolysis. Ester can go for hydrolysis. And the carboxylic acid can go for neutralization. Okay, right? This is another type of conversion. So, but this type is definitely easier. You are told X convert to Y. Y go to this. This is go to this. I mean, you are guided. You are guided. So this type of conversion is practically more easy. So if you cannot do the step 1, you can do the step 2. You go ahead. Step 3, you go ahead. I mean, you will not affect the step 1. You know, just now only one place. Here now is the sequence of conversion. So in the sequence of conversion, we are guided. This is the intermediate. This is the intermediate. This is the intermediate. So okay, give the systematic name for Y. Set the functional group present in Y. What is the Y? Okay, and give the suitable reagent and condition for the step 1 and step 2. Step 1 and step 2. Okay. Name the reactions in the step 1 and the step 2. What type of reaction? Yeah. So to be able to run the slide faster, so I won't go for the answer. Okay, why I have this one? You see the can you see the line in my slide? Can you see the line here? Why there's a line there? This line is it my line? Yeah, never mind. We go on. Okay, like this entire type of conversion. Many students say it's not easy. State the reagent and the condition for the to convert one metacyclohexene into each of the 2 organic compounds shown in below in the 2 steps. two steps. Step 1, step 2. Show the structure of the intermediate. In this case, I want to show the structure for the intermediate here. Then you give me the reagent and the condition for step 1 and step 2. So over here, you study well. If you don't study well, don't know what to do. This one go to this one without the intermediate. You want this one to this one. So this one you have really learn. You have to really learn your organic well. Only you can do this one. You can see, you can see. You cannot see, you cannot see. That's all. It's how familiar your material, you the study, how well you study your organic chemistry. If you can see this one, I see one look, I see, I know. But if you cannot see, you see, really you are lost. Maybe your teacher can guide you, I don't know. Okay, but of course I will guide my student how to see. Okay, so can you hear? I will get my answer here. Okay, I get this one. After I get this one, potential alcohol, and this is a potential alcohol. I go for oxidation. Then I'll get. So the name is MnO4 so OH negative coal. And here will be KMnO4 stroke H positive or K2Cr2O7 stroke H positive with flux or heat. Okay, like second part. Okay, I want to change this one to this one. This one to this one. There's a double bond. That's why I don't want a double bond. So okay, I will change this one to this one. When I change this one, the Cl change to this one. So what do I use? Either I use the HCl or HBr. If you use HBr, here change to Br. Here you change to your Br. You don't put the H here, please. You don't put the H here. Oh, I'm adding addition, so I add the HCl. Once you put the H here, you are wrongly because you are showing your skeleton type. So you only have the Cl here. Understood here will be 2H. 1H is you add up. Initially there's 1H here. Now you have 2H here. I mean you add 1H and the Cl. Okay. Then after that, I use the concentrated ammonia. Okay. Okay, this will be conversion. This is still not difficult because only 2 steps. Then you look here. Suggest a reference scheme of the conversion, how the conversion can be carried out. I don't know how many steps involved. I don't know how many steps involved. That question is not easy. That question is not easy. Okay, so my students have to really practice. Give a lot exercise for them. They have to practice. Okay, so here, how to get this one to this one? They have to practice. How many steps involved? Don't know. But of course, you may look at the mark given. How many steps involved? Okay, this will be conversion. Conversion. So this is the first step. Now come to by using a simple test. Simple test, it must be simple in the sense that no high temperature, no high pressure, no reflux. Okay, just a simple test. You only can go for one. A simple test has to be very simple. Just add a reagent. And then if a condition, just heat. The most is heat. You cannot reflux. You cannot say high temperature, high pressure. Okay? It just has to be this way. Then how to distinguish between the A and B. So for this type of question, you must choose a reagent that can differentiate them. I mean, among A and B, one can go for certain observation and the other does not. It must be one can, one cannot. You may have both can, also can, but must have different observation. It must be different observation. So we'll try 2 questions. Take the reagent and condition. So what part of how to go for it depends on where is the question. If this type is objective, only 1 mark. Objective, the 1 mark, just the reagent and the condition. You choose the reagent and the condition. Okay, I lost my voice. Just again. Sorry. Like state the reason for this is objective. But if this is structure, they will expect you to go for 2. State the reason and condition and tell me what is the observation. A go for what observation, whereas B has no observation, no visual change in B. But if this question is in essay, if this type of question is in essay, so it depends on how many marks. If it's 4 marks, 4 marks is the maximum. 4 marks, you will have to go for explain the observation. Why you see this observation? And last mark will be the equation involved. But if it's 3 marks, number 1, 2, and the last. 1, 2, 4. 4 marks, 1, 2, 3, 4. But if you're not comfortable, is it 1, 2 only or 1, 2, 3 only? Then you go for all. Anything is correct, they will they don't want, they just ignore. They just ignore. That make you more comfortable. I keep telling my students, you find that I want to write or not, I want to write or not. You write. By hesitating, you'll finish writing already. Okay, for example, I go here. By using a simple test, can you how to distinguish this tartaric acid? This is oxalic acid. For this one, ethane diol acid. Ethane diol acid is the IUPAC name. Oxalic acid is not IUPAC name. So this is tartaric acid is also not IUPAC, IUPAC naming. This tartaric acid, this is oxalic acid. By using a simple test, how can you distinguish? How can you distinguish between the 2 compounds? Okay, so my answer will come to here. State the reason and condition and state the observation. Look at the mark, explain the observation and equation involved. Reagent and condition. Add concentrated sulfate to the sample separately and I add the concentrated sulfate acid to the sample and heat. I add concentrated sulfate here, I add concentrated sulfate here. Okay, then what do you see? I see the observation. Okay, the oxalic acid, this is the oxalic acid, effervescent. That turn lime water chocolate, but no visual change in tartaric acid. No observation. I mean, I don't see effervescent. I don't see gas bubbles. That gas bubble can turn lime water chocolate. Although this one also go for dehydration. This one can go for dehydration. This also can go for dehydration. But the observation here for this one, I see gas bubbles or effervescent that turn lime water chocolate. Whereas this one, although also can go for dehydration, but no observable change. No observable change. I mean, this is the only answer. Then explain the observation. Then you go there. Oxalic acid can undergo dehydration to produce CO2. I want to produce, why you get effervescent? Because they produce CO2 here. Whereas tartaric acid don't produce CO2. The observation will be different. One I see gas bubble, that one I don't see. Okay. Then finally, equation. Okay, next one. By using a simple test, how you can distinguish between propanol and propana. One is aldehyde, one is ketone. So there are many ways, more than one way. I can use Tolen reagent, I can use saline solution, I can use hydroform test, I can use oxidation. More than one way. So in which way you are familiar, then you go ahead. I only show you one, right? Let's say I use hydroform test. I use the tolling reagent. Then add tolling reagent separately to the sample and heat. Okay, Popana give silver mirror. I see a silver mirror. So many students say, why silver mirror? Because you are doing any test in a test tube. Test tube. So when the silver deposited on the test tube, it's a mirror. It's a mirror. So I give a silver mirror. Whereas no visual change in the propanol. So silver mirror, give silver mirror. Okay, whereas no visual change in the propanol. Then next one, like white, acting white. Propana is an aldehyde. This is the aldehyde. Aldehyde can reduce tolling reagent to sugar, but propanol does not. So this one can do, this one cannot do. And lastly, equation. Okay, so this is the way you answer by using a simple test. How you distinguish? Now come to the state and explain observation. When state and explain, you state the observation and you have explain why you see this observation when something go on. Right. So I have to go for observation, and I explain the observation why you see this observation, and the finally equation. These are the points I have to write in. State and explain the observation when A reacted with what or treated with what. So I have to tell me what's the observation. Then you have to explain why you see this observation and equation. For example, right? State and explain when alkaline iodine solution is added to propanol. So please be more conscious on here. When you say when alkaline iodine solution is added to propanol. Okay, my teacher said when add alkaline iodine solution to the propanol, I have to heat. But why the person didn't heat? This is the star for NPM. Okay, when the question said the alkaline iodine solution is added to propanol, so it's understood. It will say understood. You have to heat. But if you are the one to answer, what is the reason and condition? You have to put heat. No heat, no reaction. So this answer is the hydroform test. So what do you see? I see the observation. What do you see? Observation. Explain the observation. Why you see this observation? Equation. Yeah. When alkaline iodine solution is added to propanol, yellow precipitate. Oh, I see a yellow precipitate. Then I can explain why you see yellow precipitate. Okay, propanol has this structure. This structure also called metaketone. Metaketone. Okay, can give positive hydroform test. Hydroform is CHI3. It's the yellow precipitate. So this one give positive hydroform test. So if you don't want to see positive hydroform, we'll give CHI3, which is the yellow precipitate. So make sure you have to put down this one. This is the important point because I have this structure. So I can give positive hydroform test. Then followed by equation. Yeah, go on. This one, number 4. Okay. The structure of the protein vanillin is given as below. The methoxy group hyphen OCH3 is chemically inert. Chemical inert means you won't touch. Any reaction you will remain at OCH3 here. Chemical, right? So you ignore here. So yeah, only on the phenolic group and the carbonyl group aldehyde. State what would you observe? What would you observe? And give the display formula for the organic product when vanillin reacts. That means you have question on what is the observation. You only have question on conversion. Okay, when aqueous albumin is added to this one, when tolling reagent is added to this one, and ethanol chloride is added to this one. So there's a combination of the observation together with the conversion. what will we observe? Okay, so do part one. So part one, what do you see? What do you see? Observe. And I want to write the formula. Okay, so my observation, structural formula. Okay, two. Why this time I don't have to explain? You state the observation. You didn't ask me to explain. Explain, state and explain. Then the observation. What do you observe? If there's no explain, you don't have to explain. Just go for observation. So bromine water. The brown bromine water decays and white precipitate form when excess bromine is added. Okay, then you go for here. Okay, on the phenolic group. 2, 4, 6. Suppose you go for 2, 4, 6, but the 2 is already blocked, the 4 also blocked, so we go for the 6. Or you can consider over here, the 6 is already blocked, so we go for 2. So this will be observation and this will be the structure. Then tolerant region. Tolerant region is on the aldehyde. On the aldehyde, nothing to do with these two. So these two will remain unchanged. Aldehyde. So what do you see? I will see a silver mirror. Then structure. Okay, here will be COO negative. Reagent, because I don't know what alkaline you add. I got COO negative. You add the tolerant reagent is what? Diamine CO1. And with the alkaline, hydroxide, ammonium hydroxide. Usually ammonia. Here supposed to be NH4 positive ammonium hydroxide. But I don't know what alkaline you're adding, so it's COO negative. Then I will let you to put silver. Okay? They don't want, they will ignore. They don't want, they will ignore because this one will give you the observation. Okay? The formula for organic products, likely, very likely, this will be the answer here. But I will advise the student you put in this one to cater for your observation. They don't want, they will just ignore. They only look for this one. And lastly, ethanol correct. Is still correct. Still correct, go for acceleration because that's ethanol here. So the main goes here. What do you get? Pleasant smell detected. Detect the pleasant smell. This is ester. Pleasant smell detected. So my answer will come here. OCOCH3. OCOCH3. Here remain unchanged. Here remain unchanged. Observation, pleasant smell detected. Yeah, identification. Identification. Identification, if you look at the passive question, especially recent one, the recent passive question, you see that a lot of questions on identification. And then this, to my experience, my students also face this type of problem. They'll find that identification, they don't know, they'll get the answer, but they don't know how to write out. They don't know how to write out. So they tend to miss the mark. So I really have to view them, practice. Each time they have to do 2 evaluation. After after my online lesson, they have to do 2 evaluation. Then you discuss next week, next session. So they really practice identification. So identification I got 2 types. One type is give a possible structural formula for the compound A. And explain your answer. How you get to the structural formula for compound A? You have to explain your answer. When you say explain answer, you cannot say, oh, what's A? What's B? What's A? What's A? Only 1 mark. What's A? Only 1 mark. How you can reduce up to the answer? Why you think this is A? Okay, such a short question here. So the mark given may be quite high. Okay, we still this question, right? C7 is 7Cl. 7 is 6O2. These are the compounds inside the question here. So first of all, you have to identify they are aromatic. They are aromatic. This is aromatic. This is also aromatic. How do you know this aromatic? Ask the teacher. Okay, aromatic. Okay. Now, once aromatic, I know that C7H7 slide, it must have a benzene. And it must have a branch. One branch or two branch. If one branch, this will be the compound. If two branch, this will be the compound. There will be two isomer here. Two more isomer. That means altogether three. One. Here's 1, 4. I show you 1, 4. We have 1, 2 and 1, 3. And 1, 4, 3 isomer. Altogether 3 isomer for this one. Okay? If only one branch, this is the compound. So whether my answer A is this one or one of the 3 isomer here. Right? Have to read, no? Okay? Yeah. Look here, aromatic. So you have to explain why you say it's aromatic. Then after that, you can see that this A can react with what? Acidified potassium manganate. So they mean from here. So I know that A can be oxidized. The word oxide got marked. A can be oxidized by KMNO4. A can be oxidized. You cannot write A can be oxidized. From where you know A can be oxidized? A can be oxidized from by KMNO4. So you have to mention this one. Okay. Then after that, your oxide product, your oxide. So if A can be oxidized, here A must have the benzylic carbon. Benzylic carbon. Benzylic carbon. Okay. Then the product here, C7H6O2. This product, oxide product, have only 2 O. Atoms without Cl. Okay. Look at the formula. You only have 2 O without the Cl. The Cl, initially your A got Cl. Where is the Cl? No more. Cl is not there. Okay. So what information you are told? I know that my Cl is not attached to the benzene. The Cl is attached to the benzene. If the Cl is attached to the benzene, after oxidation, the Cl is still there. Okay. Then the Cl is not in the benzene ring. Then what else? And only 2 O, only 1 carboxyl group. 2 O, 1 carboxyl group. If 1 carboxyl group, only 1 alkyl group, only 1 branch. Only 1 branch. So my answer will go to this one. Chlorometabenzene. 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 Not this one. This is my answer. So you use the point here. Here got mark, but this one, all this one got mark or not? I cannot guarantee you. That depends on the marking scheme. But these are the points you are supposed to write in. Then let them choose. Then finally, my A is this one. Then write equation. So do I need to write equation? That all depends on the mark given. You ask me also, I cannot tell you. That depends on the mark given. If the mark given is high, you have the right equation. If the mark given is low, you don't have the right equation. So if you're uncomfortable, you write. Let me choose. Okay, we have 5 minutes more to go. Okay, let's go for another question. This is the full question on identification. Hydrocarbon X with the percentage of mass. How many percent? By mass by percentage by mass. Okay, so it's a hydrocarbon. So we only mention carbon. Why never tell you where's another element? Hydrocarbon only contain carbon and hydrogen. So if this carbon is like that, the other hydrogen must be 100 minus. Okay, then next one, 0.125 gram hydrocarbon X occupied 49.3 cm3 at 101 kilopascal and 393 kg. Okay, 0.125 gram of the same hydrocarbon also require 36.5 cm3 hydrogen gas. Measure at room temperature for complete hydrogenation. Reduce the structure of X. I want to reduce the structure of X. And this time may come to 50 mark, 12 mark. So we look at here. So if you see this one, okay, I make it in the color, composition percentage by mass. Definitely, I know I'm going to find empirical formula. This message is for me to find empirical formula. And this message, 0.125 gram of hydrocarbon occupy 49.3 cm3 at 101 kilopascal and 393 K. This is, I'm using PV equal to nRT. PV nRT, I find the reactive molecular mass of the X. I can find what is the reactive molecular mass for the X using PV equal to nRT, PV equal to M per MR RT. Then I can find my MR. If you can find the MR with the empirical formula, you will find the molecular formula. This is empirical formula. This is your MR. After your MR and the empirical formula, you will be able to find the molecular formula of the X. The next, 0.25 gram of the same hydrocarbon can require 36.5 cm of hydrogen. This one. Look at orange one. This is for you to find. Okay. Determine the number of CC double bond per molecule of X. Inside compound X, how many CC double bond? If inside only one CC double bond, I know it must be alkene with only one CC double bond. That means one more will react with one more. One more of the hydrocarbon will react with one more hydrogen. If there are two CC double bond, one more you require two more of hydrogen, and so on and so forth. So over here I want to know how many CC double bond inside one molecule. This is the information. So you must know very well. This one I have right out. This one you have right out. Okay, yeah, we go for the answer. Empirical formula has to be done in this way. 100 gram of mass in 100 gram. So how much here? 87.8. Here will be 12.2. Then more, 87.08 divided by 12, and this one 12.2 divided by 1. And we go for simplest mole ratio. Then simple mole ratio will be 1 to 1.61. You cannot, this is 1 and this one is 2. For the form 6, you cannot round up. When can you round up? When this one is 1.9 something, 1.9 something, or 1.0 something, then only can round up. 1.2 also cannot round up. 1.8 also cannot round up. It has to be 1.9 something or 1.0 something. Then only you can round up. Okay, so I have to keep on multiply by 2, multiply by 3. So I find that multiply by 3, I will get here 5.01. 5.0. Yes, 0. Then I can round. This one is 5. 3 to 5. So only this one is correct. The rest will be correct. This is wrong. At the first place, we put 1 to 2. Wrong. Everything wrong. So this identification. Identification, you mean you're wrong. The bottom part will be wrong. Because they are related. Empirical formula will come to C3H5. 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 This is the empirical formula. Okay. Then molecular formula will be C3H5 bracket N. I don't know what's N. N is a whole number. Maybe 1, maybe 2, 3, and 4. Then I go for the PV nRT, where PV will M per MR. Then I go for the substitution. Okay. Then I get my MR. My MR come to 82.0. That is my molecular mass for X. Then using this one, C3H5 N equal to 82. Then you search out your N equal to 2. Your N must be a whole number. N equal to 2. So if N equal to 2, my molecular formula will be C6H10. C6H10. See, so many points you have put down. So it may be 12 marks, it may be 15 marks. Molecular formula C6H10. Okay, after get C6H10. Okay, turn to next page. C10, C6H10. C6H10 can be a alkene with C2CC double bond. We look at the formula CnH2n minus 2. So it may be a alkene with 2CC double bond. It may be a cycloalkene. It may be a cycloalkene. So it depends on whether one more hydrocarbon will be how many more hydrogen. From there, I do the calculation. Number more hydrocarbon, 0.125 over 82.0. So 82.0 from where? Just now I calculate from PV and RT. If this is wrong, you cannot do the calculation. If this is wrong, also the answer will be wrong. Then the number more hydrogen, okay, the volume over the molar volume. The volume is 36.5 over the molar volume in cm cube. Okay, I come to 1.50 times 10 to the minus 3. Look at here, 1 to 1. 1 to 1. So my conclusion is 1 mole of the X require 1 mole of hydrogen. That means it tells me only 1 cc double bond per molecule of X. Inside 1 molecule of X, only 1 cc double bond. So in this case, it must be cycloalkene. So my X is cycloalkene. This is cyclohexane. Okay. So this identification. So identification can be very difficult to many students. You really have to practice. Okay. Now you're already 12. I still have 10 slides for the amino acid and the polymer, but no time really. So already 12. So we have to go for Q&A. Or you want to cut down the Q&A, I go for the amino acid and polymer. Okay, it said cut off the Q&A. Many rest are telling me to cut down the Q&A. I mean, I may not have time for Q&A. So far, the response is they don't want the Q&A. They want me to continue. Do you learn? At the first place, do you learn from me? I'd like to see the response. Do you learn from me? Yes. Okay, thank you. Many say yes, 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 yes. Okay. So I have a good comment. Yes. Okay, you want to cut down the Q&A? Oh, let me because in actually this program tell me I must have Q&A half an hour. Half an hour is for Q&A. So if I cut down, I have to respect those they prefer Q&A. Any of you prefer, there must be a session of Q&A, right? I would like to see the response. Because the whole thing they tell me is 1.5 hours, then it must have Q&A for half an hour. So I have to respect them. They say this is the program. So I would like to know any one of you, many say they don't want a Q&A, but maybe some they haven't said, okay, because you are entitled for half an hour Q&A. Any one of you still prefer there must have a Q&A? Or you have any suggestion? Otherwise, I'll go straight to Q&A. You can unmute. Okay, you say, teacher, can you go back to previous slide? Do you want a previous slide? So one. If the top box block the slide. If the top can you see the whole screen or there's a checkbox come out does it block the slide? Okay I will answer. Now you start to ask question that means you want the Q&A or you want to continue. Hey, don't waste time already. Because even if later say I want to continue, I mean it's half an hour also. If you have some time after finishing the slide, we can still go on to Q&A. Teacher, can you extend time so that we can have both? Okay, so anyone want the Q&A now? Okay, just continue. Any objection? If not, I'll just continue. Continue to the last. Okay. I go on. Stop at here. Now come to amino acid. Why I want to separate them? Because amino acid, when they touch amino acid, the question they ask are totally different from the normal chapters. They are on certain things. Okay, so we see amino acid. This is amino acid. Yeah. So what they will ask? They will ask on the acid-base chapter. Acid-base characteristic. So this is your amphoteric. Why this compound is amphoteric? Okay, they ask on buffer. Why this compound has buffer action? Okay, draw the deuterium structure for this compound. Okay, give the optical isomers for this structure. Yeah. Then dipeptide, draw the structure for dipeptide, draw the structure for dipeptide. Because the amino acid is quite complicated. So to draw the dipeptide and tripeptide, you must have certain skill. And lastly, condensation polymerization. The amino acid go for condensation polymerization. So these are the questions. Of course, when it comes to here, also isoelectric point. The isoelectric point there. Okay, so these are the case. So we just go on, but of course I cannot go one by one. So I just go simply okay. Like this is the amino acid. So let me ask, what is the alpha name? Okay. Then what are the functional group present? Okay, it's same as the sound general. But okay, oxo buffer action. Start with X, show buffer action. Using equation to show this buffer action. I want to use equation to show the buffer action. That means if I add H positive, the H positive can be removed by this X. So the pH remain almost constant. If I add OH negative, a little bit of OH negative, this OH negative can be removed by the functional group in the X here. So that the pH remain almost constant. So by equation, I want to use equation. So let me use equation. It's positive. It's a single header, not reversal, single header. So I get here, like that. It's shown by equation. Then if you add OH negative, then I have this one. Okay, next one. Draw the structure for the polypeptide. Draw the structure for the polypeptide formed by using 2 amino 3-phenylpropanoic acid. So first of all, you must be able to draw up what is this amino acid. That's 2 amino 3-phenylpropanoic acid. If you cannot draw this one out, definitely the polypeptide will be wrong. Polypeptide is a polymer. Peptide stands for amino acid. The polymer formed by amino acid. I want to draw the structure of the polypeptide formed by amino acid. Okay, so the first of all, the 2 amino 3-phenylpropanoic acid have to be drawn. 2 amino 3-phenylpropanoic acid. So start with the oil acid, 3 carbon, and the one of the carbon, the last carbon, terminal carbon will have the COH, and then at the carbon 2 there's the amino, and the carbon 3 there's the phenyl. So you come to here. You come to here. So this is 2 amino 3-phenylpropanoic acid. But with this, you cannot draw the polypeptide. You have to make some arrangement. so that you can draw the polypeptide. So the important part is the NH2 and the COH. Look here, polypeptide is a polymer. So look at the functional group, go for polymerization. That is the NH2 group and the COOH group. So this NH2 group and COH is on this carbon, So make them stand at 2 terminal. Make them stand at 2 terminal, and this group will come down to the center. So what is that? So the NH2 group is one corner and COH is one corner, and the other rest will be on this one. You can put it up here, or you want to be clear. This is important. When you can draw this one, you can draw the polymer. So when you want to draw the polymer, you have two ways. One way, we use the repeating unit to put an N. You take the repeating unit, put a N bracket, and put an N. Another one, you show 3 times the repeating unit. Join 3 times. Join the amino acid 3 times. 3 amino acid join together, and no bracket, no N anymore. So which one easier? Definitely the one with bracket and easier. So we go for here. This is my amino acid. You must draw at the terminal. You cannot do this one, you cannot draw. Okay, so we come to here. So we don't want NH2, I don't want the H. The COH, I don't want the OH. See again, NH2, I don't want the H. COH, I don't want the OH. This we have 2 months to go. Sorry, we have 2 months to go. But I think like me, I haven't touched amine yet. I only finished the carboxylic acid. So I haven't touched amine. I haven't touched amino acid. I haven't touched polymer. Polymer, definitely, I've touched half in the alkene. There's addition polymerization. But another part of condensation, I haven't touched. So we have 2 months to go before our STPM. So likely, many schools haven't finished the syllabus. So if haven't finished, they may have not touched the polymer. They may not have touched the amino acid. So if in this case, you find that you may be lost. So you learn as much as you can, that's all. Okay, so you take away the H, take away the COH, and then use the bracket, a big bracket, and put an N. That will become your polypeptide. Next one. Draw the structure of the polypeptide. Polypeptide formed by using 2 amino acids and 2 amino 3-phenylpropanoic acid by 2. This is 2 amino ketone acid. You must be able to draw. And 2 amino 3-phenylpropanoic acid. So again, with this one, you cannot draw. You have to turn so that the COH and the NH2 is on the 2 terminal. Okay, NH2 on 1 terminal. So focusing on this carbon. Focusing on this carbon. So I turn. See, this carbon. COH here and NH2 here. So another one, COH here. So the COH must face the NH2. The COH must face the NH2. So I need 2. So what do you need? I don't want the H from here. I don't want the OH from here. I don't want the H from here. I don't want the OH here. Then you find that just cover that and make your line long. Join them up. Join them up. Then you put a bracket. You put a bracket. You put a bracket. Bracket. And put an N. That will be your polypeptide. Right. I want to draw a dipeptide. Draw a dipeptide. Do the same thing. Have the COH 1N and H2 1N. But this time I want dipeptide. Dipeptide means I must have 2 amino acids. 2 amino acids. So over here, here I don't want the OH, here I don't want H. Cover. And then this one join.
So you look at the dipeptide, you look at the dipeptide. Dipeptide, you still have the NH2 here at one terminal. You still have COH at one terminal. That's called dipeptide. If it's the polypeptide, no more OH, no more H. That is polypeptide. Dipeptide, tripeptide, you still have the COH at one end and H2 at the other end. That is called dipeptide or tripeptide. You know bracket, there's no bracket now, only two. Dipeptide means I'm using two amino acid, only two. Two same type or two different type. So now it's two different type. So there's no bracket N here. No bracket N here. It's not polypeptide. It's dipeptide. Okay, so you come to here. Okay? You see this one. This one. Okay. Actually, I want tripeptide. Do the same thing. I want tripeptide. So you go for 3 times. Make sure now COH one end and H2 one end. 3 times. 3 times. So take away the OH and the H from the NH2. OH from the carboxylic acid and the NH, the H from the NH2. Take away. But here remain unchanged. Here remain unchanged. You have to be this way. And then join them up. That's all. That's called tripeptide. Okay. Yeah. Okay. If you have a question, see whether you can finish earlier. The most I think is 5 minutes. Like the polymer. Right. Polymer, we have addition and condensation. You must know the definition. What do you understand by addition polymerization? What do you understand by condensation polymerization? And you must know what is called repeating unit and the structure of the polymer. How to draw the structure of the polymer. Okay, and the monomer. How to know the monomer? All this one the teacher have to teach you. Okay, spot the difference. Let me ask you. See, the 3 differences between the addition and the condensation polymerization. Spot the differences. Yeah, and then the polymer, it is the addition polymerization. Usually we touch on the polypropylene, polyethylene, polychloroethylene, polystyrene, natural rubber, SBR. But natural rubber, but sometimes will come out this. Natural rubber. Okay. This is addition. So you ask you, what type of polymerization? Addition polymerization. Okay. Then the condensation. Condensation usually go for what? Condensation will go on nylon 66 and styrene. Nylon 66 and styrene. Usually these 2 examples. Okay. So when it's addition, how to draw? If it's condensation, how to draw? So, I see. For example, but I have this one. Okay, a compound A, B, C. Okay, these are the part of the polymer. Okay, this is A, B, and C. A, B, and C. Okay, like the question will ask. Draw the structural formula for the monomer. Or monomers. You may have more than one monomer. That used to prepare A, B, C. So how to look at the the teacher have to teach you lah. Okay, so this one should be here. And what is the monomer over here? There are 2 monomers here. One monomer will be this one monomer will be this one. And over here, what monomer? This is the one. One monomer is one monomer over here. Just now we take away the condensation, we take away the H. Away the H. Away the OH from the CO. Now you put it back. You put it back. Just now I take away your H. Now I put it back. And H, take away your H, put it back. CO, I took away your OH. Now I put it back. That's all. That will be your polymer. Monomer. This will be your monomer. Okay. Yeah. Then come to here again. Classify the types of polymerization in each of ABC. These and C are condensation, and A must be addition polymerization. Classify the type of polymerization. Okay. Then what hold the repeating unit together in the polymer? I don't care. A, B, C, which top. addition or condensation? What hold the repeating unit together in the polymer? Answer must be covalent bond. Covalent bond. Okay, next. What is the major intermorphos found in between the polymer molecule in A and C? A is one. A will be van der Waals, and C will be hydrogen bond. Wait, CO, no, CO is the yes. This is the van der Waals. What is the major intermorphos? Answer is van der Waals. These two are van der Waals. Then come to this one. Yeah, but B, if you ask B will be hydrogen bond because there's an H bond here. Okay, the A and C is van der Waals, but the intermorphos between the B, the polymer B, one strand with another strand, it will be hydrogen bond. Then the texta, this texta made by polymer B and C. B and C are warned not to wash with detergent. As in this statement. Why does that a texta cannot use detergent? Because our detergent all contain NaOH or alkaline. You touch your detergent, very slippery because it contains alkaline. Then you explain why you cannot, because undergo hydrolysis, alkaline hydrolysis. One is undergo hydrolysis. This is what ester. Ester undergo hydrolysis. So amide go for hydrolysis. So you find that the textile will get torn. Okay. So you have to tell me this one. The next one. Part of the structure of minor 6 are given. Another question. This is given here. Part of it given. So the question. Give the formula for the two monomer which make nylon 6. So these are the two monomer. You can see. So the NH give back the H. NH give back the H. The CO give back the OH and OH. So this will be acceleration down to monomer. And suggest including the equation. What will happen if nylon 6 is spoiled with dilute acid? Dilute acid is H2O so H positive. Hydrolysis. So the textile will get torn. Nylon 6 is the textile. So this textile will get torn because undergo hydrolysis. The amide group can go for hydrolysis. The amide group. So I need the reaction occur. It's hydrolysis. Oxidation. The textile will get torn. Then equation just take one piece and then show the use the polymer to show the back to your monomer. Okay. Okay, all the best. Good luck. Kita sebut good luck, good luck in Hokkien. Good luck, the hard working. Okay, 2 months to go, ample time for you to study organic well. Really, I really hope that I share and you have learned. And so we have Q&A for 10 minutes. Okay, yeah, now I pass to Cikgu. You want to talk anything?
Sekejap cikgu, kita ada beberapa soalan. Kepada para pelajar, jika kamu ada sebarang soalan untuk bertanya, kamu boleh tanya sekarang ya. Puan Chua, there's a question.
Yes.
For the test to distinguish two compounds, if the question is 3 marks, I write all the 4 things. Only
that's
the
it.
equation, I write it only. Will this affect my marks?
You write equation only. You only write equation. Am I right? Just now the simple test to distinguish the two compound. Okay, you are given 3 marks, then you write the equation only. Is it what you asked?
I think yes, they ask that.
You only write equation. That means only one mark. Only 1 mark. You haven't put the reagent and condition. Okay, so it's up to the what? As last time I'm in marking 20 years, almost 20 years for STPM chemistry. So if you find that when we are marking there, we have the chip. So we will tell again, if you find that you also don't know whether to give mark or the first mark or not, because the equation already given. So it's up to the marker whether they will take this one as a reagent and condition. But the observation definitely no mark. No mark for the observation. Can I take the equation in the equation? There is the reagent. But like for example, sometimes my reagent is stolen reagent. But inside the equation, there's no wording as stolen reagent. There's no stolen reagent at all. So that depends on how you write it. Okay, but it's oxidation. You put a arrow and then put KMO4, stroke H positive. Now I know that you're using KMO4. So that depends on whether marker are convinced with your answer or not. Okay, see, I have a question there. Teacher, do you need to write the physical state for the equation? Answer is no. Unless only two things, two you have to write. Number one is the NaOH. The NaOH is solid, but what you want is the NaOH AQ. So when come to NaOH, you have to put NaOH AQ. And now one is the acid, HCl. HCl is hydrogen chloride, is a gas. But if you want it to be hydrochloric acid, then you have to put HCl AQ. Okay, teacher, the benzene, should we type or should we draw? Up to you. Circle must be inside, yes. Usually we use square bracket for polymer. I find nothing wrong now. You use a round bracket, but usually we use a square bracket. Those two need write the physical. At this time now, I think of two only. Any more question? Teacher, can we Teacher, can we draw all the solid line when drawing optical isomerism? Oh, I never practice this one. I always ask the student to go for 3 dimension. Teacher, could you go back to the slide of general? General, you want back to general. Okay, the benzene ring, you can use a circle. Unless in the mechanism that you want to show the electrophilic aromatic substitution, then you have to show the double bond because the arrow comes from the double bond. Other place, you put a benzene with a circle, hexagon with a circle. I missed any of your question?
I think that's it. I think no more question from YouTube, also Zoom. So sekiranya dah tak ada soalan daripada kamu, jadi kita akan tamatkan sesi pada hari inilah ya. Okay. Terima kasih kepada Cikgu Chua untuk hampir 2 jam ni atas pengajaran dan juga jawapan bagi soalan-soalan para pelajar lah. Okey, diharapkan kamu semua dapat menimba dan mengambil semua ilmu dalam perkongsian yang diberikan oleh Cikgu Chua sebentar tadi. Jangan lupa isikan kehadiran kamu. Kita akan bagi link yang sebentar di dalam ruangan chat dan juga kamu boleh scan QR code dekat depan kamu ni untuk kehadiran pada hari ini. Okey, jangan lupa untuk join program study community. Kamu boleh daftar di link yang kita berikan di ruangan chat dan juga di paparan. Okey, dan juga program Perkampungan Ilmu STPM Semester 3 bagi hari Jumaat ini bagi subjek sejarah. Jadi jangan lupa untuk menghadirkan diri kamu. Okey. Okay, terima kasih semua. Jangan lupa follow dan subscribe YouTube channel YPC International College dan juga follow IG serta Facebook YPC International College. Jumpa kamu lagi pada hari Jumaat ini. Terima kasih. Assalamualaikum dan selamat tengah hari. Bye-bye.
Bye-bye.